So starting off, your grades. Okay, starting off with your grades. I graded one assignment yesterday. That makes it 3 that have been graded so far. All right. Um, the active reading that I gave you guys last Monday. Okay, that was the first thing I graded. The last day to turn that in is today. The active reading that I gave you last Monday, the very last day to turn that in is today. And there were 1, 2, 3 people who didn't turn it in yet. Okay, so the active reading, the last day to turn that in is today. Then on this past Tuesday, I gave you the Amoeba Sisters. I gave you the Amoeba Sisters video. Its last day is tomorrow, and there are 1, 2, 3, 4, 5, 6, 7, 8 people who have not turned it in, including one person it came out blank. Now, I need you guys, if you think that this is why you're checking Power School. If there's something you think you turned in and it's still registering a 0 after I've graded it, then you need to check to make sure it didn't come through blank. A lot of our team stuff is coming through blank. So if it is, you need to resubmit it for me. Okay, and then tell me in Remind that you've done so. All right, so the active reading, the last day to turn it in is today. The Amoeba Sisters, the last day to turn it in is tomorrow. Then your notes, the notes for section 1 that we're going to go over today, those I'm going to grade over the weekend, but if they're not in yet, today is an 80. That doesn't suck. Okay, the notes today is an 80 if they're not in already. The thing that I did grade yesterday was the key term and objectives. I graded that yesterday. If that's not in and you got a 0 for it, today is still an 80 on that too. And again, 80s are not too bad. You need to get that in right away. Okay. Now, the thing that you turned in last night you turned in Mosamac. Last night you turned in Mosamac food webs. And today it's a 90. I haven't got that graded yet, but yesterday was 100. Today is a 90 on the Mosamac. And then I'll give you you'll have another assignment tomorrow that you're working on. Okay, so that's your grades. Do you all understand? Does anybody need that repeated? I'm trying to figure out, I've got my papers all in a mess. Does anybody need anything repeated on that as far as the grades go? Okay. Now, as far as the testing goes. Now, next week, Monday and Tuesday is your English exam for the freshmen. Freshman English exam is this coming up Monday and Tuesday, the 3rd and 4th of May. Every one of you will need to be here if you're a 9th grader. And you'll have to be at school the whole day, okay? You're not allowed to check out on English days. Okay, so you'll have to come up here Monday and Tuesday. But I will be proctoring the exam, so we won't have class. We'll have an asynchronous day, okay? Monday and Tuesday will be asynchronous days. You will have an assignment in Teams, and you'll have the little form that you have to fill out for attendance in Teams. So Monday and Tuesday, those are English exam days for 9th graders. Hang on, my daughter's wearing me out. Okay, that's fine. Monday and Tuesday are English exam days for 9th graders. They will be asynchronous in class. You will have an assignment. You will need to do that assignment, and you will also need to check in with that form that we fill out for the roll. That's Monday and Tuesday, the 3rd and 4th of this week coming up. Now, on Wednesday of this week coming up, we will actually have class. I will be here. We will have class on Wednesday. But here at school, we're also taking the U.S. history exam. So if you take U.S. history on Wednesday, you'll have to be up here and you'll just have to make up whatever we did in class. Now, moving on. So that's Monday and Tuesday, the 3rd and 4th, asynchronous. And again, I sent this message out and remind for you. Wednesday, we will be here in class on Wednesday. Thursday and Friday are also asynchronous days. That's when any of you who are 10th graders will take your English. 10th grade English is Thursday and Friday, the 6th and 7th. And again, I have to proctor that too, so we'll be asynchronous. All right. Anything else those days? Okay, so as far as next week goes, Monday and Tuesday is freshman English. We'll be asynchronous. We will be in class Wednesday. And if you take U.S. history, you have to come up to school to take it, and you'll just make up Wednesday. Then Thursday and Friday is 10th grade English, and we'll be asynchronous again. Now, moving forward, the week after that, Monday the 10th, is Algebra 1. I don't have to proctor it. We will have class. But a lot of you will be taking the Algebra 1 test on May 10th, Monday. If you are taking the algebra test, you'll just make up our work afterwards. That's Monday the 10th, next Monday. Also on Monday the 10th is pre-calculus, if any of y'all are taking pre-calculus. But again, that Monday the 10th, we will have class just like regular. Tuesday the 11th is geometry. We will still have class, but if you take geometry, you'll be up here taking your test and you'll just make up class. Then Wednesday, hang on, Wednesday the 12th, that is the biology exams. And again, I have to proctor the biology exam. So Wednesday the 12th will be asynchronous. Wednesday the 12th will be asynchronous. It's the biology exam day. Then the very last test day is Thursday the 13th. That's Algebra 2. But again, we will have class. If you take Algebra 2, you'll take the test and just make up the work. So here's the overview. Here's the overview as far as our class goes. You ready? Okay, the first week, this week coming up, the only day we have class is Wednesday. The next week, the only day we don't have class is Wednesday. Did you catch me? The first week, this week coming up, the only day that we have class is Wednesday. The next week, the only day we don't have class is Wednesday. Okay, now all of this has come through on Remind. I sent it to you also with a whole bunch of question and answer pages that if you had some of the stuff that people usually wonder about for the test, I sent all this to you in Remind yesterday. Okay. Any questions to get you started? Y'all good? Okay, so let me see. Take another picture and then get ready for our lesson. Print screen. And over here, 142. And we're going to do half of our discussion today and the other half of our discussion tomorrow. Okay, so how ecosystems work. Energy flow, food webs, food chains, okay? Energy from the sun enters the ecosystem when plants use sunlight to make sugar molecules. Now, sugar is, okay, got you, baby. All right, so the sugar that the plants make is called glucose, okay? And you know, photosynthesis is what they do to make it. And so we're going to talk a lot specifically about how photosynthesis works, how they do it, how they use it, and the chemicals involved with it. When I was grading y'all's key terms and objectives, some of y'all just gave me the words for photosynthesis, you know, carbon dioxide plus sunlight, da, da, da. I need the actual formulas, CO2. Okay, you're going to have to memorize these formulas. So we're going to spend a good portion of time going over them today. I hope you are listening well. Okay, I hope you are listening well. We're going over a lot of these, and the test on this should be coming up soon. Okay, I'll give you the details on what day we have the test. All right, so we're going to talk about photosynthesis, and photosynthesis is so important that when you take biology, if you haven't taken it yet, when you take biology, you have a whole chapter that's just photosynthesis and another whole chapter that's just cellular respiration, which is the other thing we're going to learn about. That's when you take the glucose and you actually use it. All right, so photosynthesis makes the glucose and cellular respiration uses the glucose. But you have a whole chapter for each one of those in biology. It's that important. And not just biology here in high school. When you take the sciences in college, you'll have photosynthesis and respiration. All right, so you do yourself a favor to learn as much as you can right now, okay? Because you will need it in every science class you take. Okay, you guys got your ears on? You're focusing? Got you focusing. You're focused, ready to go. Okay, all right, so photosynthesis is a process by which plants, algae, and some bacteria, it's not just plants, the algae do it, and some of the bacteria do it. They use sunlight, carbon dioxide, and water to produce carbohydrates and oxygen. Well, hang on a second, Miss Gales. This says they make carbohydrates. You just said they make glucose, and sometimes you said they make sugars. Well, which one is it? Okay, you ready? Okay, carbohydrate is like a big name, a big category. And inside carbohydrates, you have starches and you have sugars. Have you used the term carbohydrates when you're talking about dieting or working out and I got to carb up or whatever you talk about, carbohydrates, the food that you eat. Okay. When we talk about carbohydrates, we're talking about rice and potato and bread. Those are carbohydrates, noodles, pasta. Those are carbohydrates. Okay. And so, okay, Miss Gales, plants don't make noodles. No, but noodles are made from wheat. Noodles are made from wheat. Okay, so carbohydrate, okay, is a big category. And inside the big carbohydrate category, you have starches and you have sugars. Now, there's way more than one kind of sugar, but the starches and the sugars are both types of carbohydrates. The starches are the rice and the potato and the wheat and the noodles, okay? The sugars, there's about 40 or something different kinds of sugars. The sugar you put in your tea and Kool-Aid is called sucrose. The sugar that makes apples and bananas and oranges sweet, fruit sugar, is called fructose. The sugar in milk is called lactose. They all have "ose" at the end. The sugar that they put in sodas like root beer is called maltose. The sugar that plants make is called glucose. Glucose is the only one you need to worry with right now. But just know that there's like 40 or 50 different types of sugars. But the only type of sugar you need to know about right now is glucose. So can you see if the carbohydrate is the big category, and inside that you have starches and sugars, and glucose is a type of sugar. Can you see how I'll tell you that the plants make glucose, and I'll tell you the plants make sugar, and I'll tell you the plants make carbohydrates, and all three of those is exactly the same thing? You guys good with that? Can I see some thumbs? Do you understand? Thank you, thank you, thank you. You guys in the room, did you get that? Okay, all right. So the end result of photosynthesis is that carbohydrate, which is a sugar molecule named glucose, and that gives you the energy to do your daily activities. All right, so look at your formula here, and again, you're going to have to memorize your formula. All right, 6 CO2s. Can you see where my little mouse is at? 6 CO2s plus 6 waters plus solar energy is going to give you the C6H12O6. That's your glucose molecule. You will have to memorize the glucose molecule. C6H12O6. That's a glucose molecule, plus 6 oxygens. All right, so let's look at this. This one breaks it down a little bit better right here. Okay, hold on. I have to breathe. Okay. All right, there's Charles. Hang on, let me get Charles in. 148. Okay. All right. So the way photosynthesis works. Okay. The stuff on this side of the equation, that's what this is called down here. It's called an equation. The stuff on this side of the equation, those are the things that go into it to make it work. These are the ingredients. What you call this are the reactants. The reactants. That's what you call the ingredients. And then you have this yield sign, this arrow. That's a yield sign, and it is sort of like an equal sign. And this is what you get at the end. The stuff on this side, they're called products because this is what's produced. And again, you're going to need this in every single science from here on out. Are you listening good? Every single science, you need this. Make sure you're listening. All right, so on this side, these are the reactants. The arrow means yields, and it's sort of like equal. And these are the products. This is what's produced. So let's break down photosynthesis. So the plants take in 6 carbon dioxide. That's the stuff we breathe out right here. The plants take in 6 carbon dioxide molecules. And then they take in water from their roots. They take in 6 of those also. They take in 6 carbon dioxides and they take in 6 waters. Plus they add that to the sunlight they've taken in. Now there's something in here that isn't listed. None of this will work without chlorophyll. You know, the green stuff that's in the plant's leaves that allows photosynthesis to happen? Because I can sit out there in a field somewhere. I can have sunlight hitting me. I can take in some carbon dioxide. I can take in some water, but that doesn't mean I can do photosynthesis. I can have these same exact ingredients that the plant has, but I can't do photosynthesis unless I have chlorophyll, which people don't. Only plants have it. So you have to have chlorophyll to make this work. So let's look at the beginning part of the equation again. The plant takes in 6 carbon dioxides from the air, 6 waters from the roots, plus solar energy, and right here, in the presence of chlorophyll. We kind of add that near the yield sign. In the presence of chlorophyll, because it won't work without it, is going to give you yields 1 glucose molecule, C6H12O6, plus 6 oxygens. All right, so that's the formula. Now I'm going to break apart the formula. I'm going to show you exactly where each molecule goes. All right, so first off, look at your carbon dioxide. Look at it close. Do you see that you have 6 carbons right here? 6 CO2. You have 6 carbons right here. Look at your glucose. How many carbons do you need? 6 of them. This is exactly where it came from. These are the exact ingredients. We are like, baking, making a cake, doing whatever. Okay, so you have 6 carbons here in the carbon dioxide, and we needed 6 carbons to make our glucose molecule. Let's look at the hydrogen next. Right here, you have a 6 in front, but a 2 at the end of the hydrogen. That means we actually have 12 hydrogens. Okay, we have 6 H2s, so that means we have 12 hydrogens. Well, how many hydrogens does a glucose need? 12, right there. You see the mouse? That's exactly where they came from. Okay, now water's a little weird. I mean, the oxygen's a little weird. Okay, you ready? Oxygen's a little weird. Are you still with me? Okay, right here in the carbon dioxide, you have a 6 at the beginning and a 2 at the end. So technically we have 12 oxygens right here in our carbon dioxide because you have the 6 at the beginning and the 2 at the end. There's actually 12 oxygens right here. But the glucose only needed 6. So we've got some extras. But look at the water. We have 6 more oxygens in the water. So on this half, we have a total of 18 oxygens. But glucose only needs 6 of them. What are we going to do with the other 12? We got 12 extra oxygens. Here they are right here. 6 O2s. And those the plant just throws out because he doesn't need it. Okay, they just throw it out the leaves. It's almost like a plant fart, which is kind of funny. All right, because they didn't need it. They got all of the oxygen they need already, and they had a bunch left over. So they just send that oxygen out into the air. And it's a good thing they do, because that's what we take in. That's what we breathe in. So again, look at the formula, because you will have to memorize it. 6 CO2s plus 6 H2Os, that's the water, plus solar energy in the presence of chlorophyll will give you C6H12O6, that's your glucose, plus 6 O2s. Okay, now do everything you can to memorize this formula, okay? The only thing, this is something that I usually do when we're in the classroom. I'll put this on the board. The only thing I haven't brought up is, this is a plant right here. Can you see this? And it has a potato down at the bottom. Okay, you know potatoes grow on the ground. Do you remember that I said that carbohydrate is a big group that has starches and sugars in it? And glucose is a very, very simple, small sugar. This is what the plants make when they do photosynthesis. But it's not great for storage. This is what they make for their energy, and the plants don't make the glucose for us. You know, when they make the potatoes, they don't make it for us because they love us. They made that potato for themselves so that the next spring they'll have something to grow from. So that's why they made the potato. So when the plants are doing photosynthesis, they make more glucose molecules than they need at any one time. They do use them. They use them to grow and to make leaves and to make flowers and to make nectar and all this other stuff that they do. They use the glucose for that. They make extras though. Imagine, oh, hang on. Okay. Let's imagine, think about, some of you guys get paid an allowance. Okay, not everybody does, but some people do. Think about if you got one, and say you got $20 for your allowance, and the glucose molecule is like pennies. Would you like somebody to pay your allowance to you $20 worth of pennies? $20 worth of pennies is not really great way to store it, right? You can't put it in your pockets. You need a wheelbarrow. Okay, glucose molecules are small like pennies are. And so the plant doesn't want to store a whole bunch of glucose molecules. They pack them up together in a carbohydrate or a starch, just like we pack pennies up together in a $20 bill to make it easier, right? We pack pennies together into dollar bills. The plant is going to stack glucose molecules together in a starch, because it's much easier. So when the plant has a potato and it's ready to use that potato to grow the next year, that it has like 20, it's probably a potato is closer to $500 worth of pennies. And then the plant breaks them back down into the individual pennies as they use it. But they've got like $500 stored in that potato. So that's what that's for. So the pennies are very small sugars, and they get stored in the big carbohydrates, the big starches. Now, because plants, hang on, breathe again, breathing break. Because plants make their own food, we call them producers. They produce their own food. They're producers. But what's cool about photosynthesis is they're actually using inorganic molecules. Can you put sunlight in a bucket? Can you hold sunlight in your hand? No. Plants are using something that you can't actually put your hands on, like sunlight, to turn into something you can, glucose molecule. They are taking something you can't touch and hold and feel and turning it into something you can. That's why the plants and photosynthesis is so amazing. It's taking an inorganic molecule and turning it into an organic molecule. Because they make their own food, they're also called autotrophs. This is another word for it, autotrophs. All right. Do you know in a farm, when you're feeding cows and pigs and stuff, that big tub where you put the seed in or the grain or whatever it is you're going to feed your animals, that big tub that you feed your animals on the barn is called a trough. I was raised on a farm. A lot of you guys weren't. Most of you guys are city kids. But the big containers where you feed the animals, that's called a trough. The word trough means to feed. So plants make their own food. So they're called autotrophs. You see the word trough in there? Down here at the end? That comes from the word to feed. And auto, remember in your English classes, you learned that an autobiography is one that the author writes himself. Autobiography is you writing your own story, right? Auto means self. So you put the two words together, autotroph, self-feeder. The plants make their own food. Now, a lot of you guys, when I was grading your key terms and objectives, had some trouble with this. Okay, so the producers are the plants, and they're also called autotrophs. The producers are the plants, and they're called autotrophs. The next one, what do we call us? We're not a producer. I mean, I can make a sandwich or I can make some macaroni and cheese, but that doesn't mean I make my own food. Okay, we have to eat our food. We have to eat from the outside. We're called consumers. Consumers. Okay, we have to bring our food in. And so a consumer is something that has to eat other organisms or some organic matter instead of producing your own. So the other word for consumer is called heterotroph. Heterotroph. Here's the word troph again. Okay, you see the word troph? That means to feed. And hetero means outside or other than. They have to eat from the outside, bring food from the outside. Okay, so plants are producers, autotrophs. Consumers have to eat something, they're called heterotrophs. Keep them straight now, guys. Plants are producers, called autotrophs. Consumers have to eat from the outside, they are called heterotrophs. Because the next one confused people also. Well, not yet. Okay, we'll get to that in a second. So here's our first food chain. Okay, we have the plant, this clover, took the energy from the sun and turned it into something real, right? That's what they did during photosynthesis. So the plant took the energy from the sun, put it into a glucose molecule, and then the rabbit ate the glucose molecule. So the rabbit got the energy from the sun, okay, indirectly. The plant got it directly. He got it straight from the sun, and he turned the sun's energy into glucose. Then the rabbit came and took some of the clover, and he got the energy from the sun that way because the plant stored the sun's energy in the glucose molecule. The plant stored the sun's energy in the glucose molecule. And so when the rabbit eats it, he got some of that energy. And then the coyote eats him, he gets some of the energy too. But every step down the chain, they get less and less. Okay, so that's one of the things we're going to talk about today too. So when a rabbit eats the clover plant, the rabbit gets the energy from the carbohydrates. Remember, we said that's another word for the sugars that the clover plant made during photosynthesis. If the coyote eats the rabbit, some of that energy is transferred up from the rabbit to the coyote. And so in this example above, the clover is the producer because he made the energy from the sunlight, and the rabbit and coyote are consumers. They had to eat it from the plant and then from the rabbit. So the producers get their energy directly from the sun, and consumers have to get it secondhand. They get it indirectly. So they get the sun's energy indirectly. Now, when we say that all food webs start with the sun, right? Plants do photosynthesis, so every food web should start with the sun. Well, not everyone. There is an exception to the rule. Way, way down in the bottom of the ocean, there is whole food webs that never see the sun once, ever. Because way down in the bottom of the ocean, it's way too dark to see the sun. You can't do photosynthesis. Photosynthesis, the word photo in photosynthesis means light. Synthesis means to make. So plants make food from light. Okay, but there's no light in the bottom of the oceans. How can we have these huge food chains down here? Because Down in the bottom of the ocean, in some places, there are underwater volcanoes, and there are also deep sea vents where it's like cracks in the earth where magma and stuff is coming up. So sometimes it's volcanic oceans, sometimes it's just a place where smoke comes out from the center of the earth. Now, around there, along with the smoke from the center of the earth and the underground volcanoes, there's chemicals that come out. Mostly it's hydrogen sulfide, the chemicals that come out from the underwater volcanoes. There is this little bacteria that it has the capability to take this hydrogen sulfide, which is just a chemical, and the bacteria can turn that hydrogen sulfide into their form of glucose. So this little bacteria is the producer down here. They take hydrogen sulfide, which is inorganic, and they turn it into their sugar. And then something eats the bacteria, and something eats that, and something eats that, and something eats that, and you've got a whole food chain that never sees the world ever. Never sees the sun ever. Now, you can't call that the thing that the bacteria does. When the bacteria has taken that chemical, hydrogen sulfide, and he's doing his work with that, turning that into his sugar, you can't call that photosynthesis. Remember, photo means light. There's no light here, but there's chemicals. So what he's doing, that little bacteria, is doing chemosynthesis. He's making his food from chemicals, where plants make their food from sunlight. So they're photosynthesis. They're doing photosynthesis. These guys down here in the bottom of the ocean, they're making their sugar from chemicals, chemosynthesis. But that's our exception from the rule. Most everybody else, every other food chain besides these guys, it starts with the sun. Okay, we just can't say every single one because there is an exception. Let's see, what slide are we on? Okay, now this one, most of us knew this already, but some of us missed it on our questions. These are 4 types of consumers. Now remember, we have our plants. Those are called producers, also called autotrophs. The consumers have to eat. They're called heterotrophs. Right now, we're talking of 4 types of consumers. We're not talking about plants right now. Plants are our producers, called autotrophs. Consumers have to eat. They're called heterotrophs. Right now, we're talking about 4 types of consumers. We're not talking about plants right now. So the 4 types of consumers are divided by what they eat. Most of you know these. Okay, herbivores eat only plants. Do you see the word herb right there? Herbs is the same word for spices, like rosemary or oregano or thyme. You know, the spices you put in your food, those are plants that you put on your food. They're herbs. So the herbivores eat only plants. Carnivores, that's carne is the word for meat in Spanish, right? So they eat only animals. Omnivores, omni means everything. They eat both plants and animals. And the decomposers eat dead organic matter, but that's not all. They don't just eat the dead organic matter. The decomposers actually put it back into the ground for the next generation. So it's more than just eating the dead stuff so it's not lying around being gross. They're also breaking it down so that it can still be part of the next generation. And let's see. Yeah, I think I'll start with this tomorrow. Okay, y'all help me remember because it's almost time to go and I'm going to stop the video here. We're going to do primary, secondary, tertiary consumers tomorrow. Okay, and I'll tell you what that is tomorrow. Okay, let me run my meeting list. Oh, no, I'm going to do, hang on, back up here. Let's do one more picture. Print screen. And it is 2:07. All right, minimize this. Now, it is almost time to go. So let me download my attendance list. All right, and stop the video. Stop recording.